My name is Clemens. I work for Microsoft. This is Christina. She also works for Microsoft, and we're from the messaging team. And since Anna, Shay, and Kevin have been talking about streaming yesterday, we're going to talk about the other services, Event Grid, Service Bus, and I'm going to talk about a service that is named here, but that doesn't exist yet. So I'll talk towards the end a little bit about that. And it does work, indeed. As most of you will know, we have a platform made up of several services. We have numerous products. We have Event Grid that I'm going to talk about today, Service Bus that Christina is going to cover today, and then we have Event Hubs that you heard about yesterday, and Stream Analytics that you also heard about yesterday. Why do we have this multitude of services? Because they all cover different aspects of messaging. They really diverge in how you consume messages from those brokers. With Event Grid, we have a service that allows you to push messages to other destinations, and you'll also learn that there's more nuance to this by now. Service Bus, you have a JMS compatible, JMS2 compatible enterprise messaging broker with transactions and everything that has queues and topics. Event Hubs is a stream broker that provides stream consumption that is also fully compatible, 100% compatible with Apache Kafka from an API perspective. And then Stream Analytics is the way how you can go and basically connect these streams and then also can do transformations and data enrichment, etc. All of that is based on the open standards investments that we make in cloud events, in AMQP, in MQTT. These are all open standards efforts that we have been and are directly involved in. We're always showing this slide. This is the numbers are getting ever more staggering, like every time we do this. Service Bus, Event Hubs are some of the most, or are, I think, the most reliable services that exist on Azure, with well over 5 nines of weekly reliability across the entire fleet. So even when there are incidents, I'm not going to say that there are none, but even in the face of those, the overall reliability of the platform is easily over 5 nines, and in many weeks it's over 6 nines of reliability. We do 305 trillion monthly requests across messaging. We recently crossed the threshold kind of every day for 10 trillion, which is pretty significant. So we're driving lots and lots of traffic, and it just keeps growing. We're building 2 things in our team, and you've seen the demo yesterday of Fabric event streams. And you should think of these things as parallel efforts. We are and we continue to build the Azure services that we're talking about, but you see us as our team also building the messaging foundations and the metadata foundations for Fabric real-time intelligence. So we're building a SaaS platform and we're building a PaaS platform at the same time. And what you see in Fabric are effectively features that are always backed by the underlying Azure services. So we're building 2 things in parallel for different audiences. There's a developer audience for which we build PaaS services, so you can go and put your things together. And then there's a business audience that we're building the and data analyst audience that we're building the Fabric services for. Event Grid. I'm going to give a brief intro and then get to the news. Event Grid has evolved into kind of being this push broker where you can go and push data in, or the platform like Azure with storage events pushes data in, and you can go and push it to webhooks, to something that's has more capabilities, is richer. We now have on the left side, we have the ability, we have an MQTT broker built in that is different from the MQTT support that we had in IoT Hub, where we had a fairly narrow path for how you could go and deliver and fetch messages from the MQTT endpoint. And here we're now enabling you to have a free form, whatever you want, MQTT namespace, topic tree, that you can design and then also fully secure. That's part of Event Grid. And then we have numerous event publishers, as you already know that from Event Grid today. And then we also have new ways how you can go and receive events through pull semantics. Going a bit into detail on some of those. So push delivery is what we already know. Not a lot of stuff new here. Pull delivery is a new model. We have heard fairly consistently from folks that they can't put up an endpoint to get events delivered from Event Grid. Or that their endpoints, the destinations where they want to have that data sit behind some kind of a network boundary. And of course, it's hard for us to kind of make the network boundary go disappear, and we arguably shouldn't. So a way to do this so far has been to go push the data into Service Bus and then go and pull from Service Bus. But of course, that takes an extra hop, an extra service involved. So pull delivery effectively gives you a queue-like structure. And that queue-like structure, you can go and fetch a message. You can later complete the message. You can abandon the message. It's very similar to the queue capabilities. We just don't call it queue because it doesn't have all the features of a queue. But it gives you competing consumer. It gives you all the message settlement. So that's new pull delivery. Pull delivery is built on top of HTTP, but it's amazingly fast for being HTTP. We're going to have news there towards the end of the year, since the primary protocol that we use across the entire fleet of services is AMQP. And so you should see that as a point in time statement that this is HTTP. We're going to have AMQP support there as well. The MQTT broker is gives you full MQTT 3.1.1 and 5.0 coverage with an asterisk. The big asterisk at the moment, again, something that we're going to solve towards the end of the year, is that retained messages are currently not implemented, and they will be towards the end of the year. We have some special ideas on how we want to go and deal with retained messages, and that's why that's the kind of the last feature we have. But otherwise, you can use this MQTT broker for any application where MQTT is called for. So particularly, we implement persistence for all sessions. So if you have a client and the client happens to be a car, and we have car companies which are using our MQTT broker for this, and you have subscribed for messages to pull up into the car, right? You want to go and do cloud to device messaging, so to speak. And the car gets disconnected and reconnects, then all the messages that have queued up to that car are going to be retained for quite a while, I think 2 days. We have I have an extra slide for this, last will and testament too. So we have basically all the features that you want from an MQTT broker. The way how we manage access control for these brokers, for this broker, is that you create so-called topic spaces, where you're creating a policy that kind of covers a subtree, a branch effectively of a topic tree, and then you can go and assign policies to that subtree. And there's, if you go and dig into the details, there's a very clever way of how you can associate the identities of classes of devices with a topic space, so that you can onboard literally hundreds of thousands of clients. Each has their own certificate, for instance, and you can go and assign permissions to kind of all of these groups of devices in bulk. And this is all optimized for very, very large fleets of devices being connected to this MQTT broker, and you can go and attach over 1 million of those if you have those. Last will and testament is a feature of MQTT that's just new. And what that does is you can go and park a message in the broker, and when your session collapses, that message will be sent by the broker to any subscribers. So if you have a vehicle or some device that connects, it will go and effectively send a message for the case that it gets disconnected. And once it gets disconnected, that message is being sent. So you can basically park the "I got disconnected" message so that the party on the other side knows that you're currently not available. That's a feature that's built into MQTT that we now support too. What we also support is, I'm going to have to speed this up a little bit. What we also support now is custom domains. So this is the first service where we do this, where you can go and now configure effectively the Event Grid MQTT broker endpoint with your own custom domain names, where the mobile device now goes and connects to the Event Grid MQTT endpoint with its own domain name, configured with its own cert. That is important for many scenarios that use carrier APNs. These are kind of these private endpoint integrations that are being done with mobile carriers for very large deployments, which are being managed using basically custom domain names mostly. And so that's a feature where that's important. And because, especially in the MQTT scenario, where devices are involved, where consumer-facing devices are involved, sometimes these domain names pop up somewhere. And we have customers who care that those are then, Acme Motor Corporation rather than Microsoft. So that's why we support custom domains there. And then you can, with the custom domains, you can also do things like, do primary, secondary failover using your own domain name and traffic manager. In the Event Hub namespaces, that's kind of the new way of how you manage your topics in Event Grid. You have a few new features. We can now go and do push subscription also on these new kinds of topics. So we're basically filling out the holes between the old topics and the new topics. And then you also have you have the feature that I was always wondering why we didn't have that feature. Huh?
Now we have it.
Now we have it. And you can go and forward, you can publish from a Event Grid namespace to another Event Grid namespace. You can basically chain topics. And that's something that we, for some reason, didn't have. I was always surprised that we didn't have it. Now we have it, so I'm fairly happy. So now you can basically go and take an Event Grid topic and push to an Event Grid topic, so you can basically go and create integrations in this way. Quick summary of the things that we have that I just talked about. And with that, I'll hand over to Christina for some exciting things around Service Bus.
Thank you, Clemens. Hello. Oh, it does work. So I wanted to start off talking about a few of the features that we just put out the door that might be of interest. Batch delete. So batch delete is something we've had a fair number of requests for. And this is something that's going to just make it easier than just doing retrieve and action on a case-by-case basis. This works for messages and dead letter queue. This will show up at some point in the near future in the Service Bus Explorer. Not there yet. Chaos Studio integration. So what's cool is that our reliability is so high that we had customers putting in feature requests for downtime. They're like, can you please put in a way to make this thing fail? So we added a way so people could trigger an entity collapse for their own test purposes. And then last but not least that I'm listing here is the integration with CMK for customer managed keys with the managed hardware security module. This is a key vault feature that allows you to use hardware. We've got an increasing number of customers who have compliance needs that are tied to having HSM. This is something that we're doing not just in Service Bus, but also in Event Hubs as well. TLS changes. So this one is almost more of a public service announcement while I'm up here, but on October 31st, 2024, we are going to lay to rest TLS 1.0 and 1.1. We are also going to be enabling TLS 1.3 for AMQP. It's already been enabled for our non-AMQP traffic, but we ran into a small foible with, I like that word, foible, with Java clients that were using an older version of ProtonJ, where it couldn't handle TLS 1.3 to support, to 1.3 traffic. So we're giving it until the end of October for people to update their clients. We hopefully have notified everybody, put out blogs, so we're doing our best to make sure everybody is aware. But please reach out to me later if you have questions on that. And we do have details in docs and blog that describe it. Availability zones. So, anybody here like availability zones, think it's a good thing? We got one, so we should just kill this feature. Okay, so availability zones, we're working to enable this across the board, all SKUs and all Azure regions that support availability zones. The migration's been in progress for a while without you even knowing it. You don't pay anything extra for it, and you simply get even better reliability than what we already do today. This is actually in our best interest because we want to make sure you guys are happy, and if you're happy, we're happy. If you have questions, again, on availability zones in general, the document describes it, but in the interest of time, I'm going to zip a bit. Geo-replication. So this feature we've been working on for a couple years, and I'm super excited to talk about it today for no other reason than we're in London. And so it's so cool to talk about geo-replication and Service Bus, because now you can have, with 2 regions, a double-decker Service Bus.
Ooh.
See what I did there?
Very good.
Thank you. I've been saving that one. All right. So this gives you full data replication between 2 Azure regions. Do not misconstrue this to be availability zones. This is geographic disaster. It's not disaster, it's geographic replication. If you want to use it for disaster recovery purposes, that's cool, but you can replicate to other regions. We have the ability for you to promote a secondary to be the primary, which could be done, like make it happen right now, which would be a failure scenario, or you can allow it to sync up. As Kevin noted yesterday, we have synchronous and asynchronous modes. So if you want to have an RPO 0 experience, that's fantastic, which is 100% applicable to Service Bus, right? Where you want your data in sync. And this is going out for Event Hubs dedicated in public preview, and then Service Bus premium. And initially, like Kevin said, small set of regions at the onset, and we'll roll it out over the coming weeks. So, demo. It's an exciting demo. So this is going to be a fast demo because we're low on time, but you're only able to have 2 paired regions right now in public preview, so that's what we're going to use here. And then this very brief demo, we've got messages flowing to from the publisher to an event hub. We do a failover and nothing changes traffic-wise. I mean, there's a delay while the promotion happens and the consumer picks up without any problem. There is no change required to the client to do this, which is pretty slick. So let's do that. So you can see my publisher is shutting down the log stream. Let's try that again. There we go. So my publisher is publishing away happily, and I'm going to go into my Event Hubs geo-replication portal experience. By the way, you of course can do this with your own ARM commands, but we'll be adding CLI PowerShell soon. And then I've already got it configured with 2 different regions, and now I'm going to fail over. So I hit promote, I type in promote, and away it goes. I can also see my replication lag between my 2 regions. So if you want to keep track of that, that's a metric that we're making available. You'll be able to alert and do other things with it. This takes a couple moments. I don't want to say minutes, moments.
I think it takes a minute.
It's like a minute, yeah. It's still pretty quick. So what it's doing behind the scenes is all along it's been replicating traffic from the one to the next. And then during the promotion, the DNS name is being updated to point to the different region. I don't need two different namespaces. This is one namespace that essentially crosses multiple regions. And then once the DNS change happens and data has been synced between the primary and secondary yet again, then traffic resumes without missing a beat. Let's jump over here. You can see a couple errors popping in because the publisher is being slowed down from publishing. And this is where I need to fast forward.
No, I mean, it's a real thing.
Yeah, no, this is I did not take the chicken tag.
Exactly.
So
in this mode,
done.
There you go.
Boom.
Fantastic.
Yay, double-decker service bus.
So there's a few reasons why this takes so long, because what we're doing, if you push promote, we're doing a graceful drain on one side before we're lighting up the other side. So we're basically slowing down the senders to make sure that we have the last message and the last state change on one side, that we have all of that replicated on the other side, and then we do the DNS change, which also takes a little time to promote. Right? There's DNS, TTL, and all these things. And so then we know that the client on the other side, which is running through traffic manager, can go and pick this up, and then we're doing the switch over. If the region would die, so we have a 3-zone outage, then of course that entire source is gone, and you will be switching over kind of without any of the draining. You basically just continue there. There's 2 modes.
Yeah, you can force it if you want to. So
Yeah.
if you say like bad thing happened and I needed failover right now and don't worry about syncing, then boom, there you go.
Yes, there's the red button that we saw, the force.
Then the red button, once you start, you go, really, I wanted to force it, make it go faster.
Yes.
I also would add that we only have 2 regions now. We will add more. I mean, the ability to set 1 secondary and 1 primary will add at least a 3rd capability. And that you can adjust the amount of lag that you consider acceptable for replication purposes.
Yeah. So one thing that's worth noting, so we just showed event hubs.
Yes, but it works for same for Service
Yes.
Bus.
So the principles are the same, because we actually have a little bit more time than I thought.
We do?
Yes, we do, because it's only 2 past.
Cool.
So go back on that prior slide.
I can talk slower now.
Because I still want to talk. Yes. Okay.
All about Service Bus.
So the message replication in Service Bus and Event Hubs is synchronous or asynchronous. What does synchronous mean? Synchronous means that if you send a message, we will take that message and replicate it over to a quorum of the other regions. And you can pick not only one region, you can actually pick multiple regions that you want to have as secondaries. And we are going to make sure that the message or the state change is actually on disk in the other region before we act back. So you can be sure with that synchronous mode that come hell or high water in that particular primary region, your message will not be lost. It will be slower, but you're going to get effectively the ultimate consistency and ultimate safety that this important contract, this important order message will not be lost, even in the case of a total zone failure in the next moment. Asynchronous replication is just as fast. It just doesn't give you the transactionality. So basically, you can think of synchronous replication really as a transactional commit to at least 2 regions of the message that you get. Nobody else does that, because it's happening kind of under the covers. None of the other cloud services do this. Everybody does asynchronous replication of some sort, but a transactional synchronous replication is something that you can't get anywhere else. With Service Bus, it actually goes a little bit further than with Event Hubs because we also need to replicate the message state. If you take a lock on a message and you're doing 3 minutes or 5 minutes worth of work on it, and where you're doing the failover, right? You can't have that message just pop up with someone else. So the message state and all the state changes, all of your scheduled messages, all of that state gets also replicated to the other region. So that's very significant. We have actually more things coming with geo-replication that we're not going to talk about yet. But this is the start of it. What we just showed you was in the regions where we have this now deployed. And as Christina said, we're going to go and roll this out over the next few
several
months.
weeks. Yeah, it'll be available for everybody to try it out probably in about a week's time, Monday.
Yeah.
And it'll be small regions at the onset. Don't worry, the rest of them will come.
Yes.
How many of you guys are interested in this sort of thing? Yes? Nice.
Good.
It doesn't take an Oyster card, though.
Yes.
So.
Yeah.
For a service bus.
But it's like the topic of geo-replication is in every large customer conversation is basically the top ask is how you're going to do geo-redundancy, how we're going to go and set this up, how do you do disaster recovery, and this is now basically in the box, and you can go and control the failover. And as said, even if a region is completely lost, you'll be able to go and recover and go to the other region. And so, which means that once you are relying on Service Bus and Event Hubs, you can now start worrying about all the other services, including mostly your own.
Yep. No, this is like the coolest thing since sliced bread.
It's amazing.
You can add this on an existing namespace or add it on a new namespace create. You can remove it, add it back. It's your choice. It's very flexible. You can promote over, promote back. You can play ping pong however much you like. The feature is amazingly well designed.
Yes,
so.
and we kept the announcement for...
And we kept it for Integrate.
For Integrate, yes.
Because of the double-decker. Oh, wait, no, because we wanted to talk about it at Integrate.
Exactly. So thank you for that demo.
Thank you very much, Clemens. All right, let's go to messaging catalog.
The messaging catalog. That's basically the last slide that we're going to show. The messaging catalog. We have been doing work in the CNCF together with other interested parties for the last about 2.5 years now on what started as Cloud Events Discovery. We have built Cloud Events. We started this 5-6 years ago, together with Google and with IBM and PayPal and with Solace and SAP to define basically what an event is. And what came out of this effort was a definition of 7 attributes that you can go and annotate any network application message with support for HTTP, AMQP, MQTT, NATS, Kafka, and some other protocols, or how you can go and take an event and package it into JSON or into protobuf or into Avro, and just to define an event and and answer questions like what is this event? Like what kind of event is it? Where does it come from? What is it about? What's the identity of that event? When was it raised? And what's inside of that event? These are the questions that are being answered by Cloud Events. So when we were done with Cloud Events, right, we released 1.0, and now our mission is to defend 1.0. Right, we're not a project that is trying to go to get to 2.0. We actually want to go and have something that's stable. So our goal is to not create a new ship a new version. Even though we graduated in the CNCF this year. But then we were thinking, like, what's the next thing that we need? We have now defined what an event is. And the next thing was, hey, we need to define a metadata model for declaring those events. But because if you look around, for instance, the documentation of Event Grid and which events can be raised by which parts of the platform, you always find there's a table that says, here are 6 kinds of events that can be raised, and then there are sections in the documentation that then gives an example of how that event looks, with some information, some structure of the data that comes there. But mostly you're programming off that page. So we're like, we have to do something that's better than that, and we need to go and create a machine-readable version, effectively, of these documentation pages, which led us to initially an effort called Cloud Events Discovery, which we then ended up renaming into the CNCF X Registry. So X Registry is a new project that's basically by the CNCF Serverless Working Group. X Registry kind of does these, covers these areas that are on this picture. So the blue part is what we currently have as a schema registry in Event Hubs, or which exists as a schema registry in the Confluent Cloud, or schema registries in form of Epicurio, which are schema registries that are mostly there to capture, payload schemas for the reason that if you are sending data in a super compact form over the wire, you want to go and leave the metadata out, which means you're going to take a format like Avro, or you're going to take a format like Protobuf. But if you take those formats, the receiver needs to have a schema in hand to decipher the data. So the way to share those schemas is through a schema registry. That's why those things exist. And then in other cases where you have, whether the encoding format is self-serializing or self-describing, like in JSON or in XML, you still want to have schema so you can go and validate whether the data that comes to you is actually conformant with that data. So that's why we have schema registries. What we're now adding in X Registry is a so-called message definition group. So we have a registry for message definitions where you can go and constrain and declare the properties of the envelopes that the payload comes in. So you can now say for a cloud event, the cloud event needs to have this type, right? Needs to have this data content type, needs to be JSON. And it is required that you have a subject, and the subject needs to follow the following URI template pattern. And you can go and declare those things. And then you can go and take that message definition and link it to a schema. So this X registry has a schema registry section, and it has a message definition section where you can go and define those schemas. And whenever you have a definition like this, you will find that there always have to be groups, have to be grouped. So you have 1, 2, 3, 5, 10 events, which are grouped in a named group that is put in the registry, and that usually corresponds to a group of schemas that are grouped together. The reason we have these groupings as a mandatory concept is that first, usually access control is done kind of around these concepts of groups. And second, typically, you will want to do multiplexing over your communication paths. So on a single event hub or a single Kafka topic, you will usually want to send multiple kinds of events through the same pipeline. Which means I can now, when I have this registry which has these groups of event types, I can now go and create a link to that group, and now hang that group definition onto the event hub. And now when I look at the event hub and I fetch basically just this definition URI, I know that this event hub carries 5 events. And I can understand exactly what those events are, and I can exactly understand what schemas those events have. You saw a demo of this yesterday. So what Anashe showed you, event streams in Fabric uses that. So in event streams, and that's currently under the covers, but Anashe is busy designing the thing that actually makes this accessible to all of you. You will be able to go and define event definitions coupled with schemas so that you can say this event stream or this topic carries 5 events. And all of a sudden, I have a way to format, to provide schema for an event stream in the same way how you provide schema for a database. Think of that. A database has 5 tables. Each of those tables has schema to it. And the schema tells you what are the fields that are in that table, and that's how the data is organized. A database schema gives structure to the data you already have. These schemas give structure to data that you don't have yet, but that you will get because someone is going to send them to you in a stream. The endpoint registry is the way how we can, and this is the third layer on top of it, is the way how we can go and organize effectively the various endpoints that then use those definitions. So that's work that we're doing in the CNCF, in X registry. You're going to see all of this. We're doing this work first in Fabric. That's where it's going to be visible first. But we actually have in the registry, the schema registry that lives in Event Hubs, will grow up to become the Azure messaging catalog that will then go and implement this. But if you want to have an early view of these things, you can always look at the X registry project, the CNCF X registry project, and all of that is happening on GitHub. Why is that so important? That's my last thing to say.
You asking me?
Well, do you know an answer?
I have an answer.
Okay.
It helps you integrate, find things, and basically more easily build your applications because you've got a common set of schemas and know what maps to what.
Yeah.
You could programmatically generate code based on this and have integrations with a variety of Azure services or even your own applications.
That's correct. That's correct.
It's amazing.
But also what's important is Copilot, all the LLMs.
Oh yeah, AI.
They work on metadata. I encourage you to do the following thing. Create a little JSON schema that has the fields title, synopsis, and keywords. Right? Just a little JSON schema. Paste that into ChatGPT with the instruction, I will now give you content, emit data in the format with the schema that I will give you. Submit this. Then grab an arbitrary RSS feed, raw, and paste that in. It's going to do that job. You're just going to get that JSON. It's astonishing how good that is. But for us to be able to go and give you experiences like this, we need to have metadata. So organizing metadata, getting proper metadata for streams is super important, and that's why catalogs matter. We can help you more with AI if we understand what the structure of the data is so that we can go and hand that off to the LLMs and say, go and generate this, go and create samples for that, go and do a transformation of this form, write a transformer for that data. So metadata is super, super important, and that's why we're building these sorts of registries. And then last tip, I have a little hobby project.
Do you have a slide?
No, I don't have a link, but it's called Avrotize, A-V-R-O, like Avro, and then T-I-Z-E. You'll find that. There's a Visual Studio plugin, and Visual Studio Code plugin, actually, and a Python tool you can download. And if you want to transform an XSD schema into a JSON schema, or a JSON schema into an XSD schema, if you want to go and take a JSON schema and transform that into database tables, the tool will help you. It will do that by converting through Avro, but it's an interesting tool for integration developers to play with.
You missed a marketing pitch. You should have called it Rosetta Stone.
It actually says that. It says Rosetta Stone in the description.
Nice.
Yes. All right, so that's what we had.
It's very good. Well said, Clemens.
Thank you. All right, you too. Bye.